Okay. So, hi guys. I'm Zoltán Orlandi. I work here at Amarsis, obviously. I'm the project lead or lead developer of the Smart Insight project, which is basically a data warehouse solution for our clients or customers, I should say. We're not building a data warehouse for Amarsis. We're building one for each of our customers. So, slight distinction. We have an ETL tool which is developed in-house in Ruby, and we use that to extract data from various data sources, transform it. Thank you. To transform the data and finally load it into the data warehouse. And also we use our ETL tool to make data marts and various aggregations, so basically different representations of the same data. We also have a visual presentation interface which is developed in Rails, and basically it's a collection of reports and charts that you can that present you with the data, and you can filter and query and whatnot. And in addition to that, we also have an API which we support segmentation and some other operations through, and that's, as of this moment, it's still part of the Rails application, but we're working on that. So why am I telling you all this? Well, the obvious reason is to kind of plug the company. I mean, we're looking for talented developers, basically people who love working in Ruby, or at least fond of Rails. That would help. And if you like writing clean code and elegant designs, and if you enjoy programming in general, then please come talk to us, or someone who works here. So, I'm here tonight to talk to you about monads. The title kind of gave that away. The idea for this talk came from this year's Ruby conference in Barcelona. Actually, thanks to Amarsis, I was lucky enough to go in person, and I heard Tom Stewart give a very interesting talk about monads. In retrospect, I have to say his genius was that he didn't try to define monads as such. He just showed some practical usages or examples of their usages and described the monads through that. My problem was that coming from a mathematical background, I really just hate talking about things that I can't define. So undefined is not just a concept I hate in JavaScript. And so I left the conference, very, very interested in monads, and went home and started to research monads. The first thing you do when you want to research something is go to Wikipedia, right? And this should work, but it doesn't. Okay. So, Wikipedia. In functional programming, a monad is a structure that represents computations defined as sequences of steps. The type is a monad structure, defines what it means to chain operations or nest functions of that type together. So thank you for cleaning that up. It actually goes on at length to wake this up for you, if you find this understandable. And then the rest, where it gets to the practical, not even practical, the formal part, the definition and stuff, that's given in Haskell. So I'm sure it is very, very useful. Just probably not to people who don't know monads or Haskell. But since then, I obviously read up on monads some more, and I can understand them, but I came to the question of why are they so hard to understand? And I actually came up with a list of reasons, which you don't see yet. So the first one is the curse. The curse is it's a funny concept, actually. Douglas Crockford, in one of his talks, it was a couple of years ago, in one of his keynotes, said that monads are cursed. In kind of a bold statement, but he elaborated. So the curse of the monad is that once you truly understand them, you had that epiphany of, so that's what they are. You just lose the ability to explain them to anybody else. I gotta say, I think it's onto something, because I've read like dozens of blogs and articles and tutorials and whatever about monads, which by the way, not the same as nomads, no matter how many times I'm going to say nomads this evening. So monads, I've read tons of blogs and articles about them, and for every blog entry there's dozens of people in the comments section are just scratching their heads and going, what? Well, that's monads for you. The thing is that it's not necessarily a bad thing. Some of those people go on living their lives, I assume happily, without ever having to learn about monads. So they're not sorry about this. But some of them actually go on and research monads and read up on them, and they in turn have that epiphany of that's what they are. And to which point, of course, they start writing blogs, articles, tutorials about them. So poor buggers actually stand up in front of a crowd and try to explain to them in person. And in the end, we're probably just contributing to the chaos. So that's the curse of the monad. A more practical reason might be that actually they're a mathematical concept. They are rooted in category theory, and while it's not, I wouldn't say they are hard to understand without ever knowing category theory, I'm sure it helps. This might be a big hurdle to some people. I would say that I've had some mathematical background, as I said, but I haven't actually learned category theory. So if I have, my mind is just blocking the trauma because I have no idea what that is. And it is possible to understand them without this. A more compelling reason might be that they're actually a functional concept. They come from functional or purely functional programming languages. More notably, Haskell in particular is just full of monads. And some people actually say that they are irrelevant to object-oriented programming. I don't necessarily agree with that. I think they're a very useful concept, but kind of like a design pattern, if you will. But there is this, and some people do buy this. One of the obvious contributors to their being hard to understand is actually the Wikipedia page. I mean, as I said, I'm sure it helps some people. It didn't really help me. And Haskell and Burritos is probably worth a little bit of an explanation. This is again a quote from Douglas Crockford, who actually said that some of the Haskell programmers, and this is definitely true because I've read this opinion online, actually would have you believe that in order to understand monads, you need to learn Haskell first, and that's the only way. And what Douglas Crockford is that saying this is like saying in order to understand burritos, you have to learn Spanish first. It just makes no sense. The concept is ludicrous, and this is definitely not true. So what is a monad? Well, it's just an object. So you can say class if you like. Obviously, it has certain operations, or actually just two. It has a unit function, which is kind of the type constructor. I would say that in object-oriented languages, or Ruby in particular, I would define this, and actually I did, as a factory method, because this gives you the ability to use polymorphism inside your monad class. But the only real restriction here is that the unit function takes a value, a simple value, obviously an object in Ruby, and it returns an instance of the monad, and that's it. And then we have the bind function. I'm going to say that these functions in different languages are probably called different names. In Haskell, unit is called return, bind is actually bind. I've kept to the Wikipedia page and kind of what I found in the literature as a convention. So if I wanted, I could probably find better names than unit and bind for this. But if you're going to read about monads, then you're going to bump into these two functions. So that's why I'm calling those by these names. So bind actually takes a function as an argument, which in practical terms for Ruby means probably a lambda or a proc, and returns an instance of the same monad, and that's it. The only restriction is actually for f. It has to receive the value that the monad is wrapping, so it's the same when you use the unit, and it has to return a monad as well. Bind doesn't necessarily have to return the same monad that f produces, but they are all of the same kind, type, or kind. And along with these operations, monads have certain rules, just the three, two of which are really easy to understand. So it has a restriction for, or a rule for the unit function, and combined with bind. So if you take a value, wrap it in a monad, that's unit value, and bind in a function, that's function equivalent to just calling the function with the value, or it should be. And the unit function returns a monad, bind returns a monad, and f returns a monad, right? So those are the rules. So this should work. The second law, kind of a pair of the two. If you bind in the unit function to a monad, then you're going to get back the same monad, or the equivalent of the same monad. So these two rules or laws are actually just saying that unit and bind shouldn't mess with the value. So if you put something back, if you put something in, then you should be able to get it back out and work with it. That's it. The third one is slightly more complicated. It's actually what this is saying is that functional composition should be an associative operation. So if you bind in f and you bind in g, it should be equivalent to binding in a function that calls f first and then binds in g. That's not so good to read out loud, but you can see it right there. So this is a little bit more complicated, but it turns out that in reality it's not that hard to implement. So what are monads really? I mean, okay, they are these objects that have these operations and that have these rules. But what can you use them for? The most prevalent opinion about what they really are is actually just some kind of black magic and just leave me alone. Well, you'll see and you can judge for yourself. In Haskell, or actually in most purely functional languages, they are definitely a loophole to the functional contract. The functional contract says that in a purely functional language, functions can't have side effects. You can't have state. These are immutable things. Bless you. And monads are actually a good way to get around that. So much so that in Haskell, I/O operations are implemented through the I/O monad. Please don't ask me how. I don't know Haskell, but that's the way it is. I don't know if you can spot why, but if you look at the operations, bind takes a function, which is actually more appropriately a closure. But closures enclose variables, right? Hence the name. So basically, you are kind of giving a state to your monad. Not really, but almost. So they are also called type amplifiers, which is an interesting analogy. If you look at the monad as an entity that wraps a certain type of object, what you can do with it is you can build operations around the object. You're going to bind in functions that work on the value that the monad is wrapping, but the monad itself can do stuff. So that's kind of interesting. You're going to see examples for this, so don't worry if you don't understand right now. Abstract data type was actually Tom Stewart's analogy that he presented in Barcelona. It's cool as well, and it's actually very true. So the monads have these two operations, bind and unit, and based on those two operations you can define many functionalities that are common to all monads. If you want to, just as an example of abstract data type, in Ruby, think of the concept of collections. So for a collection to work, all you need is a function, one function. You need each. If you have each, you can be an enumerable object, right? You can have select, you can have reject, whatever, reduce. Monads are kind of the same. So you have the two operations, and you can base operations on those two, which work across all monads. Assembly line, as an analogy again for monads, actually comes from Wikipedia again, and it goes back to the original description that basically you can use monads to just chain operations together. So take a monad, bind something in that's going to do some additional computation. You can pass the monad around, it's no problem, and then just chain these operations. And the last one, the programmable semicolon, is actually my favorite. You're not going to understand monads based on this, but if you do understand them already, then it's kind of funny. Because in functional languages, the way to execute a sequence of operations is actually functional composition, which is a little bit harder than what most programming languages use, or actually non-functional languages. We use the semicolon. So do this, semicolon, do this. In Ruby we don't even need the semicolon. We have the option, but not the necessity. The reason why it's very appropriate to say that these are programmable semicolons is that the original operation that you want to execute goes in the bind function, and the semicolon that executes it is the monad, and it can do stuff. So it's not just an executor. It's going to be able to do almost anything. And I promise this is the last one. They are actually compared to bookkeeping as well. In a sense, it's kind of the same sense as the semicolon. So if you just think of it as I want to do this, but I have to do this as well. So it's kind of like, it really is like bookkeeping. So in order to operate, you have to do this other stuff as well that you don't really want to, and you don't want to care about it, that's for sure. But you do need to do it. And in that sense, actually, you could say, or I could say, and I'm gonna, that they are just abstractions of a certain aspect of your code. That's very true, and these are used extensively in aspect-oriented programming, which I'm not going to go into because then I'm definitely not going to fit into the time window. So let's look at a monad, the identity monad, the simplest of the monads, and let's actually write some code. So we create a class. It's going to be called identity. We need to wrap a value, right? So let's wrap a value. You have a constructor, pass in a value, we store the value, put an attribute reader on it. Okay, so we need the unit function to instantiate this. From the outside world, you should really only ever use the unit function. At least that's my understanding. I found very simple annotations that didn't keep this rule. And it is kind of a self-imposed rule since we are doing object-oriented programming. But as a concept, that should be true. So you're using the unit function to instantiate it, and basically what we're doing is just calling the constructor with the value, and then comes the bind operation. You bind in a block, a lambda, whatever, and you're just calling it with the value. So why is that useful for us? Any ideas? I would be surprised. I don't think they're useful at all. I mean, you're really not going to use an identity monad at all, because why would you? You would just call the function itself. But this is how you could theoretically use it. So you create an identity using the unit function, you pass in hello, you bind in a block that takes the value, which is hello, and it's going to have to return an identity again. That's the rule. So I'm just putting in hello and concatenate words at the end. So this is probably one of the most or more complicated ways to write hello world if you want to, and you can just get the value out at the end. Let's look at a more interesting one, which is the maybe. Are there any Java programmers here? Okay, great. I'm not going to step on any toes then. So have any of you seen this? I'm sure some of you actually have, only by just Googling. Yeah, so Java is a great language for creating null pointer exceptions. I'm actually so one of my favorite things about Ruby is that I don't have to do this. So it's just if I talk to one of my friends who's a Java programmer, I just get to sit back and just smile to myself. Okay, that's not me. But the thing is that we do this in Ruby, and it's just called the no method error. So whenever you call something on a nil, you can see I've called the square brackets operator there, it's going to return a no method error. And what this is saying actually is that you forgot to write if value is nil, then please don't do this, do something else. If it's not, then call the operation. So let's take a look at an example. So the reason I forgot to say in my introduction is that so the reason why I introduced Smart Inside as a project is that we are sometimes dealing with nested data structures, and these actually present particular kind of challenges. I can imagine that all projects have these, but we are dealing with nested data structures sometimes, and we need to just pluck a value out of them or iterate through a data structure and again just shape it into something else. And this is not a real example, but it's a theoretical one. This could happen. So we are basically just defining a function that wants to get back the lead conversion rate history. We have the metrics for the whole customer, which is an aggregated hash of values, basically. You can see we're taking the lead key, and then the conversion, and then the rate, then the history, which theoretically was probably going to be an array. So if you run this, then you're going to get a nil pointer, or sorry, a no method error. If one of your keys doesn't exist, or the customer metrics was nil to begin with. So what can you do? Well, you can make this safe. This is easy. This works. It's not really nice. If you look at it, actually, well, with one, we get a kind of a pyramid of doom going on here. We're nesting every call because we need to. And that's, if I'm going to be reading this code, that's not what I want to say. If someone new comes to the project and reads this code, he's going to leave. So, actually we're dealing with hashes, which is kind of a special example. These customer metrics could be any kind of model. They could be an active record object, in which case you wouldn't be able to do this, but since I define this as a hash, I can give you another alternative, which is this. So you take the customer metrics, and just, if it's not defined, if it's nil, then just make it into a hash and call fetch on it. What fetch does is takes the key, I'm sure probably most of you know this, but still, fetch takes the key, and if it's present in the hash, then it returns the value. If it's not, then it's going to return a default value, which you can pass in, and I'm going to pass in empty hashes there, just so I can chain these operations safely. And then at the end, I'm going to return nil as a default value, or just get the value out. So that works for hashes, but it doesn't work for anything else. What would work for everything else, basically, is something that active support supplies. I'm not sure how many of you use active support or like using active support. If you're a developer, then chances are you are using it. What active support does is mostly just monkey patches the hell out of the language, and it gives you something called try. So you can call try on a nil object, and there's two ways to use try. This is probably the harder one. So you call try on an object, and if it's nil, then whatever you pass into try as a block, it's just not going to get executed. If the receiver object isn't a nil, then it's going to get executed, and you're going to get the receiver as a parameter of the block. That's pretty cool. Actually, you can use try with just passing in the name of a method, and then it's going to call the method here. But since I'm using parameters here, it's not that clear how to do that. So, but again, I mean, this is probably better than what we started out with, the pyramid, but it's not that nice. And theoretically, I don't want to say I'm against monkey patching as a concept, because I think they're a really wonderful way to extend the language. But what active support does, if I can avoid using that, then I'm probably gonna. It's not necessarily a bad thing, but I think there is a way around that that actually gives you more functionality and a clearer, more concise way to do this, which is the maybe monad. So let's start writing this. Before we get into the code, I mean, the functionality of the maybe monad is basically, if you think about it, is all it's going to do is it's going to wrap a nil check, and that's it. Pass in a value, you bind in a function, and if the value is nil, then I don't want to execute the function, and that's it. That's all the monad is going to do. So we're passing in a value, we're wrapping the value again. The constructor does the same thing. This is one of the places where you could use polymorphism, so it's the factory method actually pays off. Well, not for me, but I've seen implementations where maybe is implemented as two subclasses, nothing and just. Actually, that's the way it works in Haskell, I think. Not here, because I just didn't want to abstract an if into two classes. And in the bind method, you call the block. This is the identity monad so far. But if the value is nil, then just return self. This works, right? The block is required to return a monad. So bind returns a monad if the value is a nil. And if the value is nil, then it's going to return self. Self is already a monad wrapping nil, which just works out nicely. We could create a new monad wrapping nil here. It just doesn't matter really. It's going to be the same thing. So what can we do with the lead conversion rate history function then? We create a maybe. We bind in a block that takes the customer metrics and returns a maybe wrapping the lead key. Okay. Are there any questions, by the way? I remember hearing about this the first time, so please feel free to ask.
Did you have questions then?
No, I don't think my mind was clear enough to actually ask anything. But anyway, so we're taking the customer matrix and we're binding in a function that's going to receive the matrix, take the lead key, and just wrap it in another maybe, because we're going to be passing this on to the other stuff, which is the lead matrix. Again, we're going to bind in something that takes the lead matrix and creates another maybe, and then so on and so forth to the lead conversion and lead conversion rate matrix. And in the end, we're going to get at the value. If you want to compare this to the try, the active support implementation, I think I would probably go with active support. But what's cool about monads is actually what I said is that they are an abstract data type. So this wrapping things in maybe, we can abstract that. We don't need that there. It's called an fmap function. Or actually, it's called fmap in Haskell, so I've kept the name. Again, not probably the name I would choose. What this does is actually binds in a lambda that takes the value, obviously, and it calls the block I'm binding in to fmap and just wraps it in the class that's executing this whole thing. So what I'm doing here, I know this might not be understandable at first, but what I'm doing here is basically just getting that maybe unit to be executed outside the block I'm passing in to bind. That's all. So what I can do with this is, this is what we started. And we take the first bind and just take the maybe unit out of there. This is going to work. We're slowly building up to the active support implementation actually, because this is kind of the same. We're calling it fmap, not try, but otherwise it does the same thing. But again, monads, abstract data types, we can build on the two basic functions that we have. And actually we can use the idea that Ruby has this concept of method missing. So you can you can send the message to an object, even if that object doesn't explicitly declare that it knows how to handle that message. So let's do that. we declare method missing, and all we want to do, method missing happens when you call a function or a method of an object that just doesn't exist.
Is this on the object, or is it just the global method missing?
This, no. This is on the monad object.
Okay.
So what we've done previously is to bind, we were passing in blocks that took the value and returned the monad. Then we created fmap. So we could just not return the monad. So to fmap we can give or pass in functions that take the value and return the value, and that will work. Which is kind of what we're going to do with method missing. So what we're doing is calling fmap with a block that executes the method that's missing from the object on the object, on the value I should say, sorry, not the object, not the monad object, but the value that is being wrapped by the monad.
So basically delegate
a
function call from the monad to the value object.
Does anyone else understand this?
Hey.
Okay. That's a good sign. So, what's our lead conversion rate history method going to look like now? We take the customer metrics, wrap them in a maybe, and just call the square brackets operator. This is going to get executed on the value, which is customer metrics, but it's going to be passed in through fmap. So it's going to execute it in a way that's going to return the monad, and you still get that nice little chain ability. So I'm just going to put the rest up here, which is this. And since you're dealing with a monad, you have to get the value first. I think that's pretty cool. I mean, this is almost what we started with. And actually, if you're working with monads in your project or your sub-module or whatever, then you don't even need to do that, because you can already pass in a monad, and it's just going to work. And that is exactly what we started with, except this time it's not going to give you an exception. I think that's cool. But let's do something else if you're still awake. The list monad. The list monad is a little spoiler at the top. It's basically just a concept that abstracts iteration through a collection, actually just an array, a list of values into a single object. So you don't have to do that. As programmers, I know we here at least often joke that if we could, then we would want to just get rid of all the for and whatever kind of loops we have in our code, because those are duplication of the same concept usually. So you could build an abstraction for that. We're not gonna, because it's just very impractical. But with the list monad, what you can do is take an example. So you have a blog, which is basically a class, a struct. Anyone unfamiliar with struct? So struct declares a class, and it declares the one I'm passing in is it's going to have an attribute called categories. So blog is going to be a new class, I think unnamed here, and it's going to get blog is the class itself. So it's going to get an attribute called categories, which you see in the example there. It's just an array, actually. So we're creating a blog class and a category class and a post class. So we're building up to having a blog which has categories, which has posts, and for the sake of simplicity, every post is just a string. So the post, it has comments, but those are just strings. And so we are creating an example as well, which is just two blogs, a couple of categories, and a couple of posts in each. What we want to do is list the words in all of the comments. That's the task ahead of us. So the way to do that is we write a word in method, taking the blogs, and we iterate through the blogs. Flatmap. Flatmap is basically calling map and then calling flatten one level. That's flatmap. since we're going to get back an array of arrays here, so it makes sense to call flat map. So we go through the blogs, and then go through the categories, and then the posts, and then the comments, and we split the comments along white spaces. Again, we're building a pyramid here, but we are getting a result, which is this. Okay, so let's do this with a monad. I'm going to call it list because that's, again, the name the literature gave it. You can call it whatever you like. So this time we're going to be wrapping values. This, to me, represents a list of values, or to the monad itself, so it's going to be an array in our implementation. And the unit function just instantiates the class by making or wrapping the value that we're passing in an array. So you pass in a value to unit, it's going to wrap it in an array and just give you back the monad. I have some empty space there. The reason is that actually Ruby already has a concept of a list of values, and it's called an array. So Tom Stewart in his talk actually kind of glanced over that little detail, and I don't want to say anything bad about it or him, because it was a fantastic talk and it helped me a lot. But actually what he did in his talk just doesn't work. So if you execute it, you can execute it on paper, but it doesn't work really in Ruby. What we are doing here is declaring that an array of values to us is the same as a list of values, and that's what I'm going to do here in the missing space there. I've actually seen implementations where people monkey patched the array object to make it into a monad, which is kind of the same thing. I just didn't want to do that because the whole motivation behind this whole thing was to not monkey patch. So what we can do here is check if the value we're passing in is already an array, and if it is, then just don't wrap it. I want to point out that I'm breaking the first monad law here. So to me that's acceptable, because to me the list monad isn't meant to wrap arrays, to wrap an array of values into an array. If you do want to do that, then you have to remember to actually wrap your value into an array before passing it in. And then you write the bind operation, which gets the block. The block, if you remember, it's gonna get the value and return back a monad. But this time we want to iterate over all of our values. So we're calling map and passing in the block to our values, which is gonna return us an array of monads. But that's not what we want. We want the values that are wrapped by those monads. So we're calling values on those monads that are already wrapped, but then, since we're mapping this, we're going to get back again an array of arrays, so we're flattening that as well. But this time we're not, so these are not just an array of values, not monads, so we need to wrap them in a list. It's a little bit more complicated than the maybe, but this is the complete implementation of the list monad, and it just works. Not an Apple thing. So words in becomes a list of blocks, which is theoretically an array, and then we bind in a function that takes a block, because now we're not we're iterating over the values in our monad one by one. So we're going to get a block there and wrap it in a list, because we need to get the categories, wrap them in a list. And the categories are again an array, so this is why we need the unit function to wrap the value if it's already an array. The rest does the same. So we do the same thing and just get the values back out at the end. So we've seen fmap before. This isn't new. It's the same implementation. We're abstracting out the call to the unit function, which is wrapping our value. And then words in becomes this. kind of nice, not certainly better than what we started with, I think. But we can still do better. We've seen method missing, so let's use that. We take the blocks and just get the categories and just get all the rest. And this is actually going to work. So it's going to return the values we've seen in the beginning. And again, the same concept works if you're already using monads and passing them in. Then you can just do this. And it's going to do what you wouldn't expect it to do, but if you're working with monads, then you probably would. So this is going to work. How am I doing on time? When we start?
We actually started at 4:15.
Okay.
It's 8 o'clock.
Yeah, that one I know. Okay, so I'm going to try to speed this up because I have a kind of complicated example ahead. This way I just...
Quick question.
Yep.
What's the sort of performance comparison between using the monad and not?
Well, actually, this is Ruby, so I haven't really thought about that. No, to me, but
because it's slow anyway, or?
Yeah, that's a joke. Yeah. But actually, to me, not this. So actually, to me, the conciseness of this compared to the original operation I had going there is probably going to be worth it most of the time. So unless it turns out that I'm doing profiling because my application is really slow, and it turns out that this is the place where I'm spending most of my time, I'm not going to touch this. I'm going to be looking at databases and whatever, anything else. This is what I'm going to want to keep.
So you don't know?
I thought I got away with that one. Yeah, I don't know. Okay, so the next one, the continuation monad. Continuations, again, being kind of a functional thing. The continuation in itself as a concept is just a function that takes a simple argument and another argument which is a function that is the same kind, so you can chain them together. It's not rocket science, and JavaScript uses this extensively. And the example, I need to speed this up. So the example is that if you call, the task would be to get the most influential Rubyist based on the GitHub number of GitHub commits in Ruby repos. So if you check out the GitHub API, it actually has some very cool functions, which if you call it, it just returns to you those URLs that you can use to get data and URL templates to get data for parameterized things like an organization there. So we're going to be calling this a couple of times. We call the API and then just get the Ruby stuff, get the Ruby repos, and then get the Ruby repo out of the Ruby repos, which is the Ruby main Ruby repo for the language. Get the contributors, and then just get the one contributor who pushed the most commits, which turns out to be someone called Nobuyoshi Nakada. This is the function that we could use, and this time it actually works. So you have a getJSON function, which is a continuation. You get a URL, and you get a success callback that you have to call at the end. And for some reason, we're wrapping this in a thread. No, never mind that now, because I need to speed this up. It fetches the JSON, parses it, and calls a success callback with the JSON, with the unparsed JSON source, so a hash, basically. And this is the way that you could use it. Since you're using continuations, you're passing in callback functions, basically, which you need to keep passing in. So you have to nest the calls, and this is what it looks like. The way you could use it, or do this with a continuation, would be to take a continuation, which this time it wraps a block to be executed, which has to call the kind of the next block after it's done. The unit function would be just an instantiation of a monad, which passes in a function or a block that executes the next block in the chain. And it passes in the value that we're wrapping. We're still wrapping values, by the way. And instead of a value accessor, this time we have a run method that takes a block and executes it. So this block is not the same that we're using with bind. This is going to receive the value that you're wrapping, and it's just going to return a result. Or you can do a computation or whatever and return a result. And this is true so much so that this isn't even necessary. So if you don't pass in a block, then we can just substitute one for you. It's going to just return a value. And then comes the bind. I'll try not to explain this because it's going to take a long time. So you call the block with the value, but you need the value. So for this to work, you have to call run because that's the only way to get to the value. But now you still have to call the next block. But in order to get the next block, you kind of have to create a new continuation because now you're not returning one. And it turns out to be this. This isn't overly complicated, but you can just start wrapping, or I did anyway. Just turn around in all this block was this, and then the next function, and it works. So you take the original code, do a continuation instead of getJSON, and this is actually I felt like this is a little bit of cheating because we're not using the init function, and if we were to use the init function, then we couldn't do this example. But actually, I implemented another monad which I named meanwhile, which you can use for this example, but I'm not going to go into that because we don't have time now. So you can do the other stuff as well with the continuations. The trick is that you're always passing in the success function or the next block to be executed, and then just passing it in to getJSON, so it is going to get executed at the end. And then you do this all the way down, and the final getJSON turns out to be this. So it's a new continuation, but the way to get the value out at the end is to do run at the very end, because up until that point, until we don't call run, nothing is getting executed at all. We're creating a continuation with just with operations and whatever on it, but we didn't say run, so nothing's happening there. When we say run, the code gets executed and it does this in a separate thread. It's not bad. What we can do is introduce functions like this one. So if you want to call the get GitHub API, or the API of GitHub, actually, you can do this with a continuation, or with a function that returns a continuation. And if you do this, then you can exchange the top continuation there. Again, if you look at the next couple lines of code, we are setting up a new call to the GitHub API with the continuation, which is like this get org stuff. We can abstract that out into a function, and then again we're still nesting, but you can turn that into this. The reason why this is actually better for us is that now every function here returns a continuation, which means that it doesn't really matter, and actually the third monad law guarantees us that it doesn't matter if we bind in additional stuff to do to the monad itself, or just do it associatively like this. And this, I think, is nicer than the original version we had. And there's not much more we can do here, but it's a pretty good implementation. I mean, if you compare it to the original one, this, I think, is very readable. But another cool thing about continuations is that you can do a maybe with it. So if you look at this code, we are wrapping an array, or a list of values actually, into a continuation, and we're just executing the length operation on the values and calling run at the end. We're going to get 5 and 4. But what happens when you call this with a nil? You get an undefined method, as one would expect. But if you have a maybe function, and let's not worry about where that function actually lives, but if you create a continuation like this, you pass in a block, and you only tell it that the only thing you need to worry about is calling the next block unless the value is nil. If the value is nil, just do nothing, that's nil implicitly. So if you use this, then this turns into this and returns nil. And that's it. So continuations are very powerful. Actually, some of the people whose blogs I've read call them the mother of all monads, because mostly you can kind of simulate all of the other monads with it, really, but it's kind of like the command pattern on steroids if you want to look at design patterns. So you can pass them around. They are not executed at that point, so you can attach new functionality to them. You can log some partial result or whatever you want, and then just execute them when it's convenient for you. If you work with JavaScript, then this sounds a little bit like promises, right? When you pass them around, just attach something new. And just to wrap this up, a very short and very contrite example of how they are useful as an abstract data type. We have a full name function which takes in a monad, and it doesn't really know what kind of monad, but it's wrapping a JSON. That's all we know. So we're f-mapping this monad, which means we're getting the raw value, and we can pass out a raw value as a result. So we're getting the JSON that's guaranteed to be in the monad because that's our expectation. It's kind of the contract of this function. And then just parsing it as a first step. And as a next step, the parsed JSON is going to be a hash, and then theoretically it should or could contain a first name and last name, which we just concatenate and then pass it out as a result. Or actually, we're passing out a monad as a result. But this gives us the full name of our players here. I have a couple of monads set up, so nothing that's a maybe wrapping a nil, adjust some value. That's again a maybe, wrapping a JSON, a list that wraps two JSONs, and a continuation, which again just wraps a single one. But if you start calling these, the full name function with these monads, for the nothing monad, full name is going to return nil, that's as expected. For the just value, it's going to return you back the full name of the person who's represented in there. If anyone likes Terry Pratchett, then there's a nod for you. For the list, it's going to return back an array of full names, and that's pretty cool. The full name function doesn't actually know anything about the monad other than it's a monad. But this works, and it works with the continuation as well. So there are other kind of monads. They can be used to validate values, to handle exceptions, and just or wrap exceptions and handle them later, whatever. I'm not going to go into that right now. Logging, profiling, you can imagine all kinds of other usages. But as a conclusion, I would say that monads are really just a tool for abstraction. So if, as programmers or software developers, we usually like abstraction because it makes our life easier, it makes our code nicer, cleaner. And in the end, the theory behind monads doesn't really matter. Right? You can use the new the constructor instead of unit, doesn't really matter, as long as they make your life easier. So just keep it clean and keep it solid. That's my advice. And if you wanted to check out the code that's behind this presentation, then you can find it in a GitHub repo. And actually, I've wrapped this up in a gem for some reason, and it's called Monadist. You can give it a try. And one last thing, I just want to quickly show this. So Tom Stewart, who gave the presentation at Barco, has a book called Understanding Computation, which is a Ruby book. I haven't read it, so I can honestly say that it's a great book, and you should just go out and buy it. It's on my to-do list, but if you're interested in that kind of stuff, then do check it out. Any questions? Sure.
Have you used this in real life programming?
I knew I was going to get that one, and the answer is no, but the reason behind that is by the time I actually understood the concept of monads, we were already behind the problem area where this could be used. So if you ever go back to that part, I'm probably going to use it. That's actually why I made the gem, so it would just be easier to use. Anyone else? No. Thank you.